Today we will start with chapter 6, triangles. So let us first of all start with the definition of triangles. What is a triangle? A triangle is a three-sided closed figure, or a polygon having three sides is called a triangle. Now we can talk about the congruency of triangles and about the similarity of triangles. Now we have already studied about the congruence part. In this chapter we are going to study in detail about the similarity of triangles. But before studying about the similarity of triangles in particular, I would first like to explain you the difference between congruency and similarity. Now, what is the meaning of congruency? When are two figures, I am not talking about triangles, I am talking about any two figures. When are two figures said to be congruent? Two figures are said to be congruent if they have the same shape and same size. Two figures are congruent if they have exactly same shape as well as same size. Then they are known as congruent figures. Whereas, what are similar figures? Similar figures and congruent figures, they do not have too much of difference. Similar figures are those figures which have the same shape but may or may not have the same size. They may or may not have the same size. For example, if I say two circles, if I draw two circles, one circle and a bigger circle. So if I ask you, are these two figures similar? Our answer will be yes, they are similar. Even though they have different radii, the radii will be different in both the cases, but their shape is same. So we said figures having the same shape but may or may not have the same size, they are known as similar figures. So we can say two circles, any two circles are always similar. Similarly, if I talk about the line segments, are two line segments similar? Are they always similar? Yes, if I take one line segment of say length 4 centimeter, another line segment of say 8 centimeter length, so are they similar? Yes, they are similar because they look alike. They look alike but their measurement is not the same. So they have the same shape but they do not have the same size. So they are also called similar figures, but they are not congruent. On the other hand, if I move on to say two figures, two line segments of same length, exactly same length, are they similar? Yes, even now they are similar because we said that similar figures are those figures which have the same shape, may or may not have the same size. The size is same, it's okay. If the size is not same, even then it is okay. But what is important is they should have the same shape. So two line segments having equal length, they are having, suppose I say 6 centimeter length. So they have the same shape and same size. So they are similar figures. Are they congruent? Yes, they are congruent figures also. So we can say in short that all congruent figures are similar, but all similar figures, they are not congruent. Similar figures may or may not be congruent depending upon whether their size is same or not. So if I say, when will two, first tell me, are all circles similar? Yes, all circles are always similar. All circles. But can I say all circles are congruent? No, all circles are not congruent, they are similar. But when do the circles become congruent? When they have the same radius. If the circles have the same radius, then they become congruent circles. The similar figures become congruent when their size also becomes same. Next is about the similarity of two, suppose if I talk about the similarity of two squares, Are two squares always similar? Two squares are always similar. Why? Because if I look at the shape, I will always get the same shape of a square, whether it is the side length is same or not, they will always look alike. So two squares are always similar, but when will the two squares become congruent? They will become congruent if they have the same side length. They will become congruent squares. If I talk about the angles, when are two angles said to be congruent? If their degree measure is same. If the degree measure of two angles is same, we call them that they are congruent angles. If I talk about two rectangles, are two rectangles similar? They will be similar only if their sides are in proper proportion, otherwise they will not look alike. So if I take these two types of rectangles, yes, they are similar, but are they congruent? No. Two rectangles will become congruent if they have the same length and same breadth, then they become congruent. Don't say that they have the same length and breadth. They have the same length and same breadth. Then they are called congruent rectangles. Next is about the triangles. Now coming to the main topic which we are going to study in this chapter, that is the similarity of triangles. When are two triangles said to be similar? Two triangles are said to be similar if number one, all three angles of two triangles are correspondingly equal to each other. Equal to each other. And second point is that all the three sides of two triangles have the same ratio, or we can say they are in proportion. If the sides are in proportion, having the same ratio means the sides are in proportion. In that case, we will say the two triangles are similar. Now, what do I mean by this? Suppose I have two triangles. One is ABC and the other one I name as say DEF. So, if I have these two triangles, let us see the condition of similarity here, whether they are similar or not. Now, in this figure, if I say angle A is equal to angle D, angle B is equal to angle F, and angle C is equal to angle E. All the three angles are correspondingly equal to each other. It means angle A corresponds to angle D, angle B corresponds to angle F, and angle C corresponds to angle E. Similarly, if I say the ratio of BC and EF is equal to, suppose I take it as 2 and then 4, is equal to the ratio of AC and DE, that is AC upon DE, is equal to the ratio of AB upon DF. Say this is 4 and this is 8. So, are these two triangles similar? Yes, because their corresponding angles are equal. A is corresponding to D, B is corresponding to F, C is corresponding to E, and their sides are also proportional. Like BC is proportional to EF. What is the ratio? 2 by 4, that is equal to 1 by 2. AC upon DE, that is also equal to 3 by 6, which is also 1 by 2. And AB upon DF, that is equal to 4 by 8, which is also equal to 1 by 2. So as all the three sides are all the three angles are equal, and all the three sides are in the same ratio or they are proportional. Therefore, triangle ABC is similar to triangle DEF. This is the symbol for similarity. We have done the symbol for congruency like this. This is the symbol for congruent triangles. For similarity, this is the symbol. No more lines below the symbol. So this is the similarity, symbol of similarity. Now, what are the correct names of these two triangles? I just wrote it as it is. If I want to write on the correct names, because that is very important step in similar triangles. Suppose the first name I have written as ABC. The first triangle I can write in any way, ABC, BAC, BCA, CAB, anything you can write. Suppose I have taken it as ABC. While writing the name of the second triangle, I must take care that the corresponding angles or the corresponding vertices should share the same position. So, angle A is corresponding to angle D. So, in place of A, I should write D here. B is corresponding to F. So, I should write F here. And C is corresponding to E. So, that is DFE. Triangle ABC is similar to triangle DFE. If you write ABC is similar to DEF, that will be a wrong nomenclature here, not wrong representation of similar triangles. Let's take some more examples of similarity of triangles, wherein we have to write down the correct names of similar triangles depending upon what is given to us about the sides and the angles. Now, when the angles are given to be equal in both the triangles, it becomes very easy for us to write down the names of the similar triangles. Like for example, if you look at the third example, here we know angle M is equal to angle P. It means M and P, they are the corresponding vertices. Then angle N is equal to angle Q. It means N of this triangle is corresponding to Q of the other triangle. And the last leftover vertex L will automatically be corresponding to the last leftover vertex of the other triangle. So once we have the correspondence between the vertices of two triangles or the angles of two triangles, it becomes very easy for us to write on the names. Suppose I choose the name as LMN. Anything you can write the first triangle. Now depending upon LMN, you write down the other name. L is corresponding to R. So I will first write R. M is corresponding to P, so I will write P, and N is corresponding to Q, so I will write Q. LMN is similar to RPQ. Yes, if you change the name of the first triangle to MLN, then you can write it as PRQ. Depending upon these, they will also change. So in this case, there is not much of a problem. Now coming over to the first part, where none of the angles are given to be equal, but only the sides are given to be proportional. So the sides are AB is proportional to QR, AC is proportional to PQ, and BC is proportional to PR. This is given to us. AB and QR are proportional. So what I have done is, I have put a single tick on AB and a single tick on QR. I can't put this kind of a symbol because that shows equality of sides. Here the sides are not equal, but they are proportional. So I'm just putting a tick on both the sides. AB and QR are proportional. Second pair is AC and PQ. So I have put 2 ticks on AC and 2 ticks on PQ. And the third one is BC and PR. So I have put 3 ticks on BC and 3 ticks on PR. Now looking at these sides, can we write down the correct names of similar triangles? Suppose I write ABC. Writing the correct names is not difficult once you set up the correspondence between the vertices or between the triangles, between the angles, sorry. So here if you see, look at vertex A. Vertex A lies between single tick and a double tick. Now, which vertex in this triangle PQR lies between the sides having single tick and a double tick? That is vertex Q. So, can I say A corresponds to Q? Similarly, if you look at the vertex B, now B corresponds to, B lies between a single tick side and a triple tick side here. In this triangle R is the vertex which lies between single tick and 3 ticks. So B corresponds to R, and the third vertex C will automatically correspond to P. So when I write triangle ABC, I should write triangle QRP, and that is the correct names of two similar triangles. And remember, this is a very important step in similarity, because all the questions, whenever you will solve the questions based on similarity, this is the most important step. That is why I am discussing it in the very beginning of the chapter, was to make you understand whenever you write down the names of similar triangles, they should be written in proper manner with the correct names. Now in the second figure, whenever you have one angle given, that is very easy for us because this and this are already equal. So we have the correspondence between E and X already. Now let us put the ticks here, EF and XZ. So EF single tick, XZ is a single tick. DE upon XY, so double tick on DE and double tick on XY. Now the third side is a blank side. So E, we have already set up the correspondence between E and X. If I look at the vertex F, it is lying between a side of single tick and no tick at all. So which vertex lies between a single tick and no tick in the other figure? That is the vertex Z, single tick and no tick here. So I can say F corresponds to the vertex Z, and the third leftover vertex is D. Now D lies between double tick and no tick. So here Y lies between double tick and no tick. So these are the correspondences between the vertices. So I can write triangle DEF, suppose. First one I can write in any way I feel like. Now D corresponds to Y, so I will write Y first. E corresponds to X, so I will write X. F corresponds to Z, so I will write Z. So this is the correct names of two similar triangles. Now after this, let's move on to the similarity of two polygons finally. Like triangle is also a polygon. So in the same way we can define the similarity of two polynomials as we have defined the similarity of two triangles. Two polygons are said to be similar if their corresponding angles are equal and their corresponding sides are in the same ratio or they are in proportion. The sides are proportional to each other, then the two polygons are said to be similar. The same definition we have for triangles as well. Now what is the difference between similarity and congruency? In congruency also the first step is the same, corresponding angles are equal in both the triangles, and second is corresponding sides are also equal in case of congruence of triangles. Whereas in similarity the second point differs, and that says that sides are not equal but the sides are proportional. That is why we say in similarity the size is not the same always. It may or may not be same. So what kind of relationship we have between congruency and similarity? We can say all congruent figures are similar figures, but all similar figures are not congruent figures. And when do similar figures become congruent figures? When they have their same size, or when their size is made equal or same, then they become congruent figures. Now moving on to the first exercise of chapter number 6, 6.1. First question is fill in the blanks using the correct word given in brackets. All circles are obviously similar. Unless we mention the radius of the circle, we do not know whether the circles are congruent or not. Here if I say circles, all circles of radius 4 centimeter are, then we would have said congruent. But here radius is not mentioned, so we'll say all circles are similar. All squares are again similar. All dashed triangles are similar. Isosceles or equilateral? Obviously equilateral. Isosceles triangles may not be similar, because isosceles triangle we can have sides like this, we can even have sides like this, equal sides, but they do not look alike. Okay, so isosceles triangles are not always similar, but equilateral triangles are always similar. Two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are proportional. Next is question number 2. Give two different examples of a pair of similar figures. So as we have discussed so many examples, any two squares, any two equilateral triangles, they are the examples of similar figures. Non-similar figures may you can say any two figures, circle and a square, triangle and a square, and you can look for so many other figures as well. Third question, state whether the following quadrilaterals are similar or not. Quadrilateral is again a polygon. So for similarity, first of all, the first point I need is that the corresponding angles should be equal. So if I look at the angle, in this figure, the angles are 90 degrees. All the angles are 90 degrees. But here we can easily see the angles are not 90 degrees because the figure is a tilted figure. And the tilted figure can never have right angles. So the first point itself is not correct. So we'll not even look for the second point. But if you look at the second point, you will find that is true. Why? Because if you look at the ratio of the sides, 1.5 upon 3 gives you 1 by 2, 1.5 upon 3, 1.5 upon 3, 1.5 upon 3. All the sides are proportional, but because the first step, that is corresponding angles are not equal, that is why these two figures, they are not similar. Now I would like to take some more examples of how to write down the correct names of similar triangles, because that is the base of this chapter. It's a very important point. You must understand this. So let's see, in this first question, three sides of both the triangles are given. First you need to make out which sides are proportional. Okay, like you just can't say AB is proportional to PQ. You can't say that. You have to say that the ratio should be same of all the sides. So what ratio should I make? Can I say AB upon QR? That is equal to 2 by 4. That gives you the ratio 1 by 2. Similarly, BC upon PR will give you 2.5 upon 5, which again gives you 1 by 2 on simplification. And AC upon PQ is 3 by 6, which will also give you 1 by 2. So by taking this kind of pairing of the sides, we are getting the ratios to be equal. It means these are the proportional sides. So let me put a tick against those sides, AB and QR. So I will put a single tick on AB, single tick on QR. BC and PR, so double tick here, and PR double tick. And third one is AC and PQ. This is AC and PQ. So once we know the proportional sides, now we should be able to write on the correct names. With angles it becomes very simple, but with sides you really need to put in effort to write on the correct names of similar triangles. Now look, if I write on the first triangle as ABC, as I told you, first triangle can be written in any way. If I write it as ABC, now let's see A. Look at the vertex A in the figure. It lies between single tick and three ticks. In the other figure, which vertex lies between a single tick side and three tick sides? That is the vertex Q. It lies between a single tick and three ticks. So A and Q are corresponding vertices. Then we have B. B lies between single tick and two ticks. So single tick and two ticks is R in this case. And the third one is C. C lies between two ticks and three tick. So here vertex P lies between two ticks and three ticks here. So it is P. So I will say ABC is similar to QRP. Similarly, move on to the next one. Second, here I can make the pairing of 2 and 4 because they give us the ratio 1 by 2. I can make the pairing of 3 and 6, that also gives me 1 by 2. But if I look at this and this side, 2.7 and 5 will not give me the ratio as 1 by 2. It means all the sides are not proportional. So when all the sides are not proportional, by the definition of similarity, we'll say these triangles are not similar. So no need to write down the correct names of similar triangles here. Had it been 2.5 in place of this, then we would have done it. And moving on to the third part, we see angle M is equal to angle Q. So angle M and angle Q will form the corresponding vertices. First correspondence we have already got here. Mn is proportional to PQ. Mn upon PQ will give you 2.5 upon 5, and that is equal to 1 by 2. And ML is corresponding to QR. ML upon QR will also give us 5 upon 10, which is equal to 1 by 2. So now let's write down the correct names of these two triangles. If I want to write LMN is similar to triangle. Now look at the vertex L. L lies between double tick and no tick. Here R lies between double tick and no tick. So I will write R. L and R are the corresponding vertices. And M we already know is corresponding to Q, and the third leftover vertex N will be corresponding to P. So LMN is similar to RQP. Now the last part, fourth part is angle D is equal to nothing, it's not given here. Angle E is equal to angle Q. It means E and Q are corresponding vertices. But what about others? None of the sides is given to be proportional. None of the angles is equal. So in this case, what you will do is find out the third angle as well. Once you know the two angles are given, 70 and 80 is 150. So by angle sum property, I'll get the third angle to be 30 degrees. And here by angle sum property, I'll get the third angle to be 70 degrees. So again, D is corresponding to P, E is corresponding to Q, and F is corresponding to R. So triangle DEF is similar to triangle PQR. So this is how we write down the names of similar triangles, the correct names of similar triangles. Please do a lot of practice on these type of questions because they are going to be the most important part of your exercise questions.